Hello everyone, welcome back to another video with Mr. Coder, and in today's video I'm going to show you how to solve Dr. TC from Codeforces Round 1020 Division 3. So as you can see, it doesn't say it here because I'm a tester, but I'll be explaining through the problem starting with question A. Dr. TC. So in order to test his patient's intelligence, Dr. C, Dr. TC created the following test. So he makes a binary string A of size n, then he writes down n binary strings S1 through Sn, which is each of size n. Note that A is not written on the board. So the ith string occurs from A by flipping its ith character. So formally the following property holds. For any ij such that I and j is between 1 and n. If I is not equal to j, then it's just the same character as in the string a. But if I equals j, then it's the other variable. So it's just 1 minus whatever is aj. So then in this case, it's not equal, which means s of ij is equal to 1 minus a of j. So thus the patient needs to count the number of ones written on the board. So an example of what this is all saying, it might be confusing at first, but if a equals 1, 0, 1, then if we write it down 3 times since you need n binary strings, then notice that uh you if I equals j, that would be this one, and this one. So you'd flip each one. So this one would flip into it would flip into a 0, and then similar with these two, it would be 1 and 0. So then, as you can see here, this is how it is: 0, 0, 1, 1, 1, 1, and 1, 0, 0. So then this is what if the binary string A is equal to 1, 0, 1, this is how the board looks like. So then the total number of ones in this case is equal to 5. As you can see, these are the 5. So you need to count how many ones are there total, given that you're not given the full matrix, you're only given the string A. Now, the fortunate thing for us is that n is less than or equal to 100, so any O of n squared will always work. Even n cubed, but n squared was basically the max time complexity that you could really do, even if you tried. But so as you can see in this example, we counted the 5 ones. So to solve this problem, one way you could do it is just to literally brute force it. So you could go for each I from 0 to n minus 1. You can change it temporarily in the string, then count into a variable outside of the for loops, and then just print it out. Or you could also do this in O of n time. And there's a few ways of doing this, but the way I did it was I did the inputs, and then I have the total is equal to 0, and then the number of ones is equal to 0. And then I just count how many ones there are. And then I loop through again, and this one's like going through the horizontally. This is going through vertically. So if the value of like the diagonal is equal to 1, that means that that one's being changed into a 0. So it's a total number of ones minus 1. Otherwise, it's 0, and that's going to be changed into a 1, which means that all the other ones stay the same, but the 0 turns into a 1, so it's O plus 1. And then afterward, you print out the total. And note that even though there is a way to, instead of having this for loop, you could just have like total plus equals to number of ones times O minus 1 plus the number of zeros times O plus 1, but it doesn't impact the time complexity because you always need to have at least O of n for counting and like the string input. So that's the solution for Dr. TC, uh, which is question A. So the key thing for this problem is just to notice that it's mainly like understanding the problem and knowing just how to brute force it. I mean, you really only need to know how to brute force it. But and the trick of having O of n time is Like you can still have this brute force counting as long as you only have one loop. So you don't need to like do all that math on the paper. You can just have total plus equals O minus 1, total plus equals O plus 1. The time complexity still remains at O of n per test case. So yeah, thank you for watching this video. If you like this video, please like and subscribe, and I'll see you in the next one. Bye.